Hello, so we are looking at Math 2 Part 3, and we're dealing with percent error. First thing off, you should know and take note that on Table T, about the third one down, you'll find percent error, the formula for it, so you won't ever have to memorize it. All right, so what is that? Percent error is the difference between the measured value and the true value as a percentage of the actual true value. So it's a percentage of how your estimate may be off compared to the accepted value. So a student measures, we're going to do an example. A student measures a radius of a circular sheet of paper and finds that its radius is 15 centimeters long. However, the label on the package says that the radius is 17 centimeters long. Calculate the percentage error in that measurement. We're going to take it step by step. So first off, take note, what's the measured, what's the accepted. Then you're going to plug in, it doesn't say here, but I always write it down. This is my measured minus accepted over accepted times 100. So you're going to subtract the measured value from the accepted value. Now, if you were to actually do that, you'd end up with a negative number. You will see why in a second. Just to make it easier on you, just make it positive. All right, so take the bigger one minus the one that's not as big. All right, so 17 minus 15 is 2. It should be 15 minus 17 equals negative 2. But the next step is take the absolute value. So the absolute value of something is just taking the positive of it. So if it's negative, it's still going to be positive. If it's positive, it's going to stay positive. So in this case, a negative 2 would go to a 2 or a positive 2. So just make it easier on yourself and just subtract the bigger one from the smaller one, okay? Then the next step, you're going to divide because remember, PEMDAS, we did the subtraction, now we're doing the division. So we're going to divide the 2 centimeters by 17 centimeters. And I'm going to keep two significant figures. Why? Because right here, I have two significant figures. And I'm going to keep the two significant figures throughout the whole thing. I know it's a little different from what I was talking about in class, but it'll make sense to you, okay? So it ends up being, rounding off, to 0.12. All right? So we get to that point. We got the first part done. We got step 3. Now we got one more step. That next step, that last step, is you're going to times it by 100. That's going to make it a percent. And you will always label it with a percent. The unit is percent. Pardon me. All right, so we're going to do a little bit of a couple more examples, right? And so the first one we got, I'm automatically going to write this down. Why? Because I always like to have it down. It's easier for you. So now that I have this written down, I want to go and read through what it's asking. A student estimated a mass to be 250 grams, but upon careful measuring of it, found the actual mass to be 240 grams. What is the percent error? So the measured is what is that estimated. The actual is it's listed as actual. So I'm going to plug in those numbers. So 250 grams minus 240 grams. I'm going to have that all over 240 because 240 is the actual, and I'm going to times that by 100. All right, so when I plug in the numbers, I get that. So I'm doing PEMDAS. So the next thing I'm going to do is I'm going to subtract. So 250 minus 240, you should get 10 grams over 240. You're going to times that by 100. All right, so I'm keep doing it. So I'm going to plug that into my calculator that I have. 10 divided by 240, and no, it's not 2.4. I get that number. Now looking at my significant figures, because there's no decimal, I'm going to go rule 4. There's only 2 sig figs. So I've got an answer of 0.041666667. So what I'm going to do is I'm going to go to 2 decimal places. So my answer is going to be 0.042 because 6 is higher than 5. So I'm going to move it up, times it by 100 to get my percent. And I'm going to be 4.2% error on that one, okay? All right, let's look at the next one. Next one's a little bit tricky because it almost looks like it doesn't give you the second part, the actual, but you know the actual. A student measured the temperature of a boiling water and got an experimental reading of 97.5. Okay, what's the actual boiling point of water? It's 100 degrees Celsius. So I write my formula down. I plug in my numbers. 97.5 degrees C over 100 degrees C times by 100. All right, so I'm going to calculate this out. This is 100 minus 97.5. Remember, we go with the subtraction first. Find 2.5 degrees Celsius over 100 degrees Celsius times by 100. So I divide that by 100. I should get a 0.025 times that by 100. I know it's going to seem a little redundant. So once I times it out, I should get 2.5. All right. That is, percent. I forgot my units. 2.5%. There you go, 2.5%. Last but not least, this is a multi-step thing. Let's read it out and see what it's asking. So Joe measured the volume of an object 5 times. The result of the object is 34.5, 34.9, 34.2, 33.4, 35.9. What is the average experimental results? So what you're going to do is you're going to add all of them up and divide by 5 to get the average. The average, when you add them all up, is 34.58. I have a little bit of an issue with this because of sig figs. We're adding up, so it's got to stop in the tenths space. So right here, I'm stopping here, so I got to look at that number and see if I got to round up. So I do have to round up. So it's going to be 34.6 milliliters. That is my average experimental. Or my measured. All right. So what is the actual object? So the actual volume of that object is 34.1 milliliters. What is the percent error? So we have our, you noticed on my board, I kind of kept it up there. There it is. Measured minus accepted over accepted times 100. So we're going to do it 34.6 ml minus 34.1 ml over 34.1 ml times 100. All right, I'm going to do the top first. So 34.6 minus 34.1, you should get 0.5. Okay, we're going to keep in context. Put a little note, 3 sig figs. Because that's what we're starting with. 0.5 over 34.1 ml. Hold on. Yep. Times by 100. So it should look like that. Okay. So I'm going to calculate it out. 34.1 equals. All right, I get this number. It's very similar. But remember, I want 3 sig figs on this. So you're going to look at rule 3 for this to help you. So I'm going to write down mine. It's going to be right there. 0.147. Remember, because of rule 3, those two don't count for sig figs. I'm going to times that by 100. And I'm going to get 1.47%. There was a 1.47% error. Okay? And that is it for today. If you have any questions, please ask. I hope you have a great night.